Good evening to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. So here this is yet another video about heat treatment. Today we are going to see another type of annealing, which is known as spheroidizing. Right. This spheroidizing annealing is a heat treatment process used primarily for steels, particularly those for high carbon content. So it is used for this high carbon content steel to improve their measurability and formability. So here the main aim is to high carbon steels are really hard because of the high carbon content. The carbon content ranges from 0.3 to 0.8. So due to this high hardness, it is very tough to do the machining part. So this spheroidizing helps to improve the machinability and formability. So this process aims to soften the steel and modify its microstructure by converting the carbides present in the steel into round spheroidal shape, looks like a bullseye, right? Okay. So this spheroidizing annealing typically involves other heat treatment also has three processes. The first one is heating. So the steel is heated to a temperature slightly below the eutectoid temperature. So the eutectoid means it's one of the reaction, or it's just known as one of the invariant reaction is seen in the anchoring history. So this eutectoid temperature converts one solid to two different solids upon cooling and two different solids upon heating forms a single solid. So these three solids have different physical properties and chemical properties, even mechanical properties. So this eutectoid temperature, which is the temperature at which the steel transforms into a constituent phase. For hypoeutectoid steel, the steel is which is less than 0.77% of carbon. The temperature is typically between 650 degrees Celsius to 700 degrees Celsius, and taking Fahrenheit into consideration is 1200 to 1300 degrees Fahrenheit. For hypoeutectoid steel, which is more than 0.77% of carbon, 8% of carbon, the temperature is slightly higher. So taking soaking into the consideration, the soaking, once the steel reaches the desired temperature, it is held at the temperature for an extended period of time. This soaking period allows the diffusion of carbon atom within the steel, promoting the formation of spheroidal carbons. So after the soaking period, the steel is slowly cooled down to room temperature, and the cooling rate is not crucial but for spheroidizing annealing, but it is often done in the furnace to prevent rapid cooling and the reintroduction of internal stress. Right? So this spheroidizing annealing helps to improve the machinability of steel by softening it and reducing its hardness. So the round carbides formed during the process are less abrasive than the original carbides, and making the steel easier to machine. So additionally, the softened steels are more ductile and less prone to cracking or distortion during the subsequent forming or machining operations. So this spheroidizing annealing is commonly used in manufacturing of precision components such as bearings, gears and cutting tools, where the tight tolerance and excellent surface finishes are required. As this spheroidizing take into the consideration, we have a iron called spheroidizing iron, that is SG cast iron, which is used to make the brake drums for the heavy vehicles. So here the spheroidizing, where we are going to convert a plate like things or a thread like carbides into bullseye, that is into spheroids, so that the hardness is slightly reduced. So due to this reduction in hardness, it is obviously there will be increases the material is softened and it can be easily machined. So the main objective of this spheroidizing is to improve the machinability and also to improve the improve the machinability, and to also formability of the particular material, so that the material can be easily machined. Thank you. That's all for today.